Welcome to this afternoon session on the first Nutrients in a Circular Economy Summit 2022. My name is Professor Bernedette McCabe, and I am the Director at the University of Southern Queensland's Centre for Agricultural Engineering, based here in Toowoomba. Today, I'll be giving you an overview of the work that we will be conducting as part of the ARC NiCE Hub, and that is regarding the optimization of urine-derived and biosolids-derived biofertilizers. Before we begin, I'd like to introduce the project team. I will be leading the project as Chief Investigator, and we also have a support from co-investigator Dr. Dio Antil, who is an adjunct research fellow at the Centre for Agricultural Engineering at USQ, but is based with the CSIRO Food and Agriculture Business Unit in Canberra. We also have Dr. Serge Marchuk, who is a research fellow within the Energy and Bioresource Recycling team at the Centre for Agriculture Engineering, and also the support of Ms. Eleni dos Pazos Silva, who are also providing research assistance along the way. Now, the biofertilizer work is contained in two work packages. Work package 1, which aligns with project 4.3 in the ARC Hub, will look to evaluate and demonstrate UGOLD and ERVL efficacy in field trials, and we'll be partnering with urban utilities. Work package 2 is Logan Home Biosolids Gasification Project, which has received the financial support from Pyrocal, Pty Ltd, and also Logan Water and Logan City Council. Both Work Package 1 and Work Package 2 will be providing information around the usefulness of both urine-derived fertilizers and biosolids-derived biochar, which is going to be really important in understanding end-of-waste codes. So both work packages will be working closely with Queensland's Department of Environment and Science. Just looking now over to project objectives, I'll first of all look at work package 1, which is looking at the evaluation and demonstration of UGOLD and ERVL efficacy in field trials. This work package has two main objectives. The first one is to develop the specifications for novel urine-derived biofertilizer products that firstly meet the requirements for field application from a physical property perspective, and then secondly, looking at a biofertilizer product that also meets nutritional needs of plants, and therefore we will be focusing on the chemical composition side of things there. The second aim of work package 1 for urine-derived biofertilizers is to experimentally evaluate the proposed formulations and product format to determine the fertilizer replacement value, or FRV, of the urine-derived biofertilizer products and develop guidelines for use on crops and parklands. The second work project is called the Logan Home Biosolids Gasification Project. And again, under two main project objectives, we'll firstly look at understanding the effect of a conversion technology called the continuous carbonization technology on heavy metals content and mobility in a byproduct. Firstly, by assessing the potential risks due to heavy metals, namely zinc, chromium, copper, nickel, and lead. And then looking at the nutrient effects, primarily nitrogen and phosphorus, leaching in soil treated with the byproduct. The second aim of work package 2 will look to determine the suitability of the byproduct as a biofertilizer. We'll be doing this by looking at two key areas. Firstly, the nutrient availability of N, P, and K from the byproduct to soil. And secondly, the byproduct as a potential fertilizer with respect to plant yield by determining the agronomic response in interconnected interconnected studies involving glasshouse and field experiments. In terms of the methodology, I thought I'd just outline it by 4 points, which will be generically applied to both work package 1 and 2. So first of all, we'll be undertaking an agricultural requirements analysis by comparing both the biofertilizer against the inorganic fertilizers. And this is important both from a contamination point of view and also a nutrient point of view. So in regard to heavy metals, we'll be also assessing the heavy metal contents of synthetic fertilizers as well, as this will become important when we're assessing regulatory guidelines. We'll then secondly develop product chemical and physical specifications that will help to inform the product development of both the urine-derived biofertilizer and biosolids-derived biofertilizer. And then from those specifications, we'll look to evaluate the proposed formulation by conducting agronomic studies at both field and glasshouse scales. And then with all of these points combined, we'll provide results which will then go into the development of guidelines for efficient and safe use of both biofertilizer materials. If we look at the first point of our methodology, we'll be looking at contamination studies in terms of the heavy metals, particularly around the biosolids-derived biochar. And then we'll also look at the agronomic performance, particularly around nutrients in Glasshouse Trials. And so we can see here at the top image to the left, we have facilities and laboratory which will be undertaken in terms of leaching experiments. We will be conducting those primarily to assess heavy metal mobility in biosolids-derived biochar. And to the right here, we have an image of the types of glasshouse trials that we will be conducting in our facilities. And these will be done to determine the yield to nutrient response relationships for both the biofertilizer materials that we will be investigating in work package 1 and 2, and then to compare with the standard mineral fertilizers such as urea. And if we look at the Glasshouse Trials, we have previously conducted trials with biofertilizers which have utilized ryegrass. And we use ryegrass because of its ability to grow quickly and the ability to obtain multiple cups in a short period of time. So we'd be looking at setting these up quite soon, probably in order to take the right season, we'll be looking to set it up around mid-August and run it right through to summer. And what we'll be doing is taking dry yields from all those treatments that we were doing and recording monthly in order to establish relationships with amount of nitrogen and phosphorus supplied. So we'll be doing these both for urine-derived fertilizers and also biosolids-derived biofertilizers. In terms of the field scale trials, we'll be looking at both using sites here at USQ. And so if you look at the top right-hand corner here, we have sufficient land available here at the Toowoomba campus so that we have an ag plot just outside of our building, which is quite fortunate. We'll be able to then plant different crops and also assess these sites at around Brisbane and also Parklands. In these field trials, we look to compare biofertilizers with urea to assess 3 main areas of interest. First one is to assess the productivity over a long-term, say 4 seasons worth of crop, given the duration of the project. We'd also be looking to assess the soil resilience of the soils for which we are applying the biofertilizer, and then also to assess the heavy metal buildup in soil or the recovery in grain or biomass. As the project goes on, we would also be looking at other contaminants, namely around, say, microplastics or emerging pollutants or the persistent organic pollutants as well. So I would just like to end on a very high level note in terms of the industry benefits and outcomes of doing this type of optimization of the biofertilizers. Because once we have understood exactly what the monetary value is, and to also make sure we have the right guidelines, this could present a potential income stream through the sales of the product and licensing of the technology, or enabling for reduced or avoided costs associated with disposal by increasing agricultural recycling. Another benefit is also to reduce farmers' reliance on mineral fertilizers, and this also could go toward not just the agricultural sector, but the peri-urban sector as well, and also parklands and the horticultural sector. As we know, we're living in times of looking at a fertilizer crisis in terms of the price of urea, and so they're obviously likely to go up even more in price. And so with the associated benefits in terms of nutrient and organic recovery, we will also realise this in terms of the actual opening up markets to biofertilizers into the future. And lastly, we could assess a monetary value in relation to the sale of the product based on the overall urea fertilizer market in Australia, which is estimated at around about $1 billion Australian dollars. And as I mentioned, the biofertilizer market is set to only increase into the future, as recent international studies have reported. So that's just a general overview of our work that we are going to conduct as part of the ARC Nutrients in a Circular Economy Hub. We are really looking forward to commencing this project with our project partners, and I've got my details there below if there are any questions to follow up. Thank you.